Good morning. Let's make something interesting. Write me, please, a program in C that will create a window, display my first program, add the numbers from 1 to 10, and display result. Let's see. Okay, this is my code. I will take this and I have a tiny C compiler. This is the C file. Let's see. I will put the code. Increase the window. It's very interesting. All the code was right in a second. Very interesting. Where we add these numbers is here. Here I try to increase. So we have this sum from add numbers, correct. I think the compiler do not accept definition of integer here. I will put outside a for cycler. This a little bit old my compiler. Okay. I will put again this sum value of result. They will store the value of result, and I will put here a specific value. Let's say a. Okay, so you see here this I equal 1, the start of the cycle. This I it's less can be equal with 10, less and equal, and I increasing increment, increasing by 1. I work in that manner because I want to put a sign in the file, application file. We will see. File. I will save this, and let's see. Now I will start with this. Change directory to tiny C. I have a tiny C on this computer. Tiny C program dot C. Okay. Now I have to put correct name. Tiny C in that form. Let's wait for the results. Okay, everything was all right. It's not very interesting that I can create a program in C, C++ or Python or what other I want. And just in second, just I tell I want this program, and voila, this program. Let's execute. Go to program, and I will execute. Okay, this is my window. It's right my first program, and the sum of the numbers from 1 to 10 is 55. Why sum of the number 1 to 10 is 55? Because 1 plus 10 is 11. 2 plus 9 is 11. 3 plus 8 is 11. And so on. We have a half of 10, that means 5, pairs of 11. 5 multiplied by 11 is 55. Okay, I understand. I will close this windows. Everything alright. This is my code, and I will search again. From editor. Okay, I wait. I see it's a very simple program, very simple to use. I open file. Okay, let's see. I think this is my application. Okay, open. What we have here, I will zoom in, but close. Not in this manner. So I don't know if you see it's too small. So this is the signature of application file in Windows. This and this. The next one is the dimension of the file, the starting of code segment, the starting of data segment, the starting of stack. It's right in division and the remainder of division of 5, 1, 2. But okay, I don't work in this way. I will search here for my string. Okay, I will search for my string. It's a little bit more to do in that manner. Okay, my first program. I will change. I will write my next program. Okay, uh, and sum of number from 1 to 10. I will put here 1 to 8, let's say, is 9. 1 to 8 is not 1, let's say 2 to 8. Okay, I will try to zoom, but now save as. I will save this. I will save, doesn't matter the name, in this file. Okay, save. Okay, so is in documents saved. This, let's see. Wow, this is an X, this is an application, can be dangerous. Here, run anyway. Okay, what we see here? The same application. First, my next program, I don't put correct, but I want to roll to my next program. A sum of number from 2 to 8 is 55. Is not 55, but you see what's happened. I modify just the string 2 and 8. I must to modify the calculus. Let's see again. Okay, I put here a side. There is many of A. I will search for this. I will continue to search that manner. And voila, this is the value AA. Okay, so remember the program. I will put this value AAAA. After this I will assume it's 0, and after this I will start for I equal 1 to I the stop condition be less and can be less or equal to 10, which I have 0, I have 1 and 10, but take care in 10 is A in hexa. Okay, so We have here my data A. I try to increase again. A. Okay. We search for the same pattern in this number to 0, but look here is 1, and I want to be 2, for example, but not 32, just 2. How to now he take me how to put number 2 here. Number 2. Let's see now. Okay, it's number 2. So I start to number 2 to 10. I expect this 10, 0A. 0A, it's 10. You see here, I have 10. 0A, but I want to 8. Let's see if I put 8. Okay, I put 8, but I let the dimension the same. Okay, I will save. The same. Overwrite, yes. Save. Okay. Let's see now the program. 1 second. Here. Okay. Execute the same. Executed download application. Okay. Run anyway. I wait. And you see the sum of number from 2 to 8 is now 35, not 55. So you can do this simple task to an application program for Windows. But ethically, there is to do that only on your program, on what you write in. Okay, I will close that. I will close that, and I will close that, and I will close that, and here this is the program in C. Okay, I will let this open, and I must close that. I have here a very simple program. I will execute. Okay, whatever. Application file is this. Very good. Okay, this is so file. I will open. I will open this program, an application. Open. but I don't know how to change the font. I will save this. I will save this in C. This time is C. It's okay. Okay, and I close this. Let's see now. This is my C and tiny C. This file, I will close this, enlarge. This is an assembly. I obtained the code, but I see this AA. You observe this AA. Okay, so this value is put in here in AX. Extended AX, and the value of AX is put here in memory this time. Here is double word. It's a double word value. Okay, so I need these two instructions to put this value in memory. Where? Here. Okay, so I did again this. Let's see the opcode. Here we have the opcode. I have one opcode here, and here I have the same opcode, but is different in location and memory where I put this value. I put this value in this location in memory a second, and let's see, I put here, because you know this value AAA must be memorized somewhere, and the compiler decides so. Okay, so the same process here. I put 1 in memory. Here I put 1 in memory here, and now I read the exactly memory from above, and I put in extended AX, and now AX, you will see, will be compared with 10. Here is, I put some explanation, here is 10, maybe equal to 10. Okay, so I make a comparison between the value and number 10, which is wrote in this case as A. Here we have jump. If the number is greater than 10, jump out of the cycle. There is 4 cycles. There is 4, and for 1 to 10, for I equal 1 to 10, jump out of the cycle. But if I was inside the cycle, I will execute this unconditional jump 0 0 4 0, you see there, 1 0 4 0 in the end. Let's see where I jump. I said 1040 in the end of this number is here. No, is here is 104D. It's not 0. This is here. Okay. So I have this jump where I do this. I take from the memory 2 value. If you remember this value from the memory and this value, I can and make an addition. Here is something like this: I equal I plus 1, or something like this. I do not know exactly if it's this or this, but anyway, you can write in the simple here like incrementation of. So doing so, maybe I save something from time, because I don't take from memory. Anyway, this is the program. I will try to explain in another way. Here is no operation. Let's see. I will zoom out. Let's okay. I will prefer full screen. Let's see what I have here. Program. No. I will close this. And one note. Okay. Oh no. Okay. This is the program. Okay, so this is sum. 1 second, please. to take my pen. Is sum equal 0 a. Here we have sum equal 0. Okay, so here we have I equal 1. Okay, so here we have compare with 10. Let's say I less equal 10, less or equal. Here we have jump if equal. Here is a decision to remain in cycle. Decision to remain in cycle. It's in connection with this condition. Let's say we have here an if. Okay, the condition to take out of the cycle and let's see. This program I said condition take out from of the cycle. I will search. I will put not here 3. I will search now for addition. Now for addition. Not there. Another search. Addition. Now this is the C program. I need this. Okay. So I will do the same print screen. I prefer full screen. Okay, this is one note, and this here I will take out from memory and I will add in this situation. That's mean where to write I equal I plus 1. You see here I can modify and put plus whatever I want. So here, move from memory to processor register. Again, I'll put again. I will enlarge, I will zoom in. So, from memory, okay. Let's explain this way. From memory, this location I put here in processor math register extended AX. AX is 16 bits and extended is double. I put here in CX. Extended CX is double, 32 bits. So I add 1 extended CX in extended AX. That the compiler know to do, but I can write this in the simple manner that, and I expect to save some time in that way. I remember a joke. Coworker of mine said something like this. Maybe we know must to learn programming from you, because you know that procedure is time consumption, but there is a industrial process, and time was critical. That is, guy. I hope you like it.